Okay, notes 4.5 part 2. We're going to look more at our graphs of sine and cosine. So we're going to do the parent functions of all 6 trig functions, talk about domain and range, amplitude, period. And so then these notes really focus here on the phase shift and the vertical shift, and then we can graph these as well. Okay. So we have C and D added here to note in their phase shift and their vertical shift. And so you see these C. So C is the phase shift. And if it is greater than 0, if C is greater than 0, you go right. If it's less than 0, you go left. But keep in mind, inside the parentheses, there's these minus signs. So just like with other functions, if it's inside, you're going to do the opposite. So if you see x minus 2, you're going to go right 2. Okay, and then D, this is our vertical shift. Again, just like any other function, this is what's going to move you up or down. So if it's bigger than 0, you're going to go up. If it's less than 0, you will go down. When it's outside, you don't have to worry about the opposite. Okay, so just a general rule, graph the original function, and then graph the shifts. Okay, so let's take a look. Y equals 3 sine of x plus pi over 2. So just like yesterday, let's go through and do our amplitude and period. So our amplitude is 3. The period is 2 pi over b. So there would be something out here with that 1, or with that x, if there were a period change. So 2 pi over 1, which is 2 pi. And then inside, that means there's a phase shift. So phase shift, we have plus pi over 2, so that means it's negative pi over 2. So we're going to go left pi over 2. Okay, so I'm going to graph the original without the phase shift. So I'll go ahead and do the amplitude of 3, period of 2 pi, but I won't move it left yet. So period of 2 pi means you mark your pi over 2, pi, 3 pi over 2, and 2 pi. Okay, our amplitude is 3. And then sine. So I'm here, and here. This is, I'm going to use just a dotted line here, a dashed line. Okay. So now when I think about going left pi over 2, well, my increments are in pi over 2, so that makes this pretty easy. So I got to go left pi over 2, so I have a negative pi over 2. So I'm taking all of these points here and I'm shifting them left, basically what looks like 1 unit. Because my units, my increments are already in pi over 2. Okay, so that's that one. Let's look at another one. Okay, so another sine graph. I want to rewrite this though, so I have the trig function part first, and then I have this -1 at the end. So the first thing I'm going to do is write it as 2 sine of 4x minus 1. Okay, so my amplitude is 2. My period is 2 pi over 4. Okay, which makes this pi over 2. And I don't have a phase shift because I don't have anything added or subtracted with parentheses in here with the x. So that -1 at the end is a vertical shift. That's -1, which means down 1. Okay, so just like the one I did before, I'm going to go ahead and graph the parent, like with the amplitude and period that's given here, and then I will shift everything down 1. Okay, so doing the period here, remember we break it into 4 pieces. So I'm going to divide this pi over 2 by 4. So pi over 2 divided by 4 is pi over 2 times 1/4. So pi over 8. Okay. The amplitude is 2. And I'm going by pi over 8. Here's pi over 8. 1 pi over 8. 2 pi over 8, which is pi over 4. 3 pi over 8. And then 4 pi over 8, pi over 2. So your last one should be what your period is, the pi over 2. Okay, this is sine again. Mark the parent function. Dashed lines here. Okay, and then there's a vertical shift where it goes down 1, so I'm going to go down 1 to -3 here. I'll move all of these points down 1. And finish the graph. Okay, next one. Okay, so I have a little bit more going on here. So 4 cosine of 3x minus pi plus 1. The first thing I need to identify is with this period and phase shift together inside the parentheses. So if I go back to this, notice that our period change here is outside that parentheses. So I have to make sure that I do that if I see a phase shift and a period change. Okay, so what I mean is that I'm going to rewrite this, and I need to pull that 3 outside of this parentheses here. It should be out front. Your phase shift should be inside with x by itself. So if I'm factoring out a 3, if I'm dividing by the 3, that's like distributive property backwards. So I took the 3 out of here, and then I am taking the 3 out of pi, which means dividing by, so I have that pi over 3. Okay, so think about distributive property backwards. If you were to work backwards and distribute, you're going to get 3x, and then 3 times negative pi over 3 is negative pi. right, so I want to look at it like this. So my amplitude is 4. My period is 2 pi over 3. I have a phase shift of pi over 3, which means right. And I have a vertical shift of 1, positive 1, so I'm going to go up. All right, so lots going on here. Okay. I have my amplitude of 4. So 1, 2, 3, 4. And 1, 2, 3, negative 4. My period is 2 pi over 3. So I need to break that into 4s. So dividing by 4 is multiplying by 1/4. Okay, so that's 2 pi over 12, which is pi over 6. I'm grouping by pi over 6. Okay, so I have pi over 6, and then 2 pi over 6, which is pi over 3. Okay, 4 pi over 6. No, wait, 1 pi over 6, 2 pi over 6, 3 pi over 6 is pi over 2. 3 pi over 6 is pi over 2. And then 4 pi over 6 is our 2 pi over 3. So my fourth one should match the period. All right, so this is cosine. So I start up here, and here, and then here, here, here. Okay. That's the parent, which I probably should have dashed that one in. Erase it and dash it in instead. And actually, technically, it's not the parent. It's just the original without the shifts. The parent function would be where your amplitude is 1 and negative 1, and then your period is 0 to 2 pi. Okay, so here's the original without the shifts. So I have a phase shift, so a horizontal shift, right 3, or right pi over 3. So looking at my scale, that's going to move it over 2 places. So we're going in pi over 6 increments. So 2 pi over 6 would be pi over 3. So I'm going in pi over 6. This was 4 pi over 6, so I have 5 pi over 6 here. And then 6 pi over 6, which is just pi. So I get all the way to pi because I'm going over 2 units when I break it up to pi over 6. And then I also go up 1. So I'm going to go up here to 5. Okay, so I'm going to take all these points and go right 2 units and up 1. Here, to here. Here. 1, 2, up 1. Okay. Okay. So that was kind of all of that together. It should look like we shifted over 2 units and up 1. So for this last problem, we're just going to state the amplitude, period, phase shift, and vertical shift, but we won't actually graph it. So the first thing I notice here is that I need to factor out my 3 again. Factor out my 3 again, which is dividing by 3. I'm going to rewrite this as y equals 1/2 cosine, factoring out the 3. So that leaves me with x plus, so when I factor out the 3, I divide by 3, which is multiplying by 1/3, x plus pi over 6. All right, so go through. Okay, amplitude is 1/2, period, 2 pi over b, so over 3. Feel free to pause this and try to write this out on your own first, and then play it to check. Okay, our phase shift is a positive, it's a plus pi over 6, so negative pi over 6, which means we're going left pi over 6. And then our vertical shift is -2, which means we're going down 2. Okay, so you're going to want to get started on the homework if you haven't already. You want to do the 4.5, page 533, the 4.5 worksheet, and the 4.5 part 2 that's in Pearson. Feel free to email me if you have any questions.